This is a guide video on how to use CHOR technique in determining functional group from a molecular formula. On the first page of the card, there is an exercise. The instruction of the card is to draw a structural formula from the given molecular formula. I will show you the technique by doing question number 1, number 3 and number 5. Question number 1, molecular formula C3H8. Step number 1, write the number of CH and O from the molecular formula in the box. So we have 3C, H, 8H and 0 oxygen. Step number 2. Step number 2, double up the number of carbon. So here we have 3 carbon, so double up, so we will get 6. Hydrogen, we have 8. Now, in the second step, we compare the amount of C and H. So between 2C and H, we have 2C is less than number of hydrogen. So 2 carbon less than hydrogen indicates that this compound only has all single bond. Step number 3, determine your path. So we have 2 carbon less than hydrogen. So we take the path, the above path. So 2 carbon less than H and we have no oxygen. So if 2 carbon less than H means that all single bond and without oxygen. So the compound has no functional group and the compound is alkene. So step number 4, we want to write the structural formula from molecular formula C3H8. So we write carbon, we have 3 carbon and all the carbon has single bonds. So all carbon has 4 single bonds. And now we complete all the bond with hydrogen. So 1, 2, 3, 4, 5, 6, 7, 8. So now we have a molecular formula C3H8 and a structural formula C3H8. Example 3, we have C3H6O. So the first step is write the number of carbon, hydrogen and oxygen. So carbon we have 3, hydrogen we have 6, oxygen we have 1. Step 2, double up the carbon, the number of carbon. So we have carbon 3, so double up the carbon, so we will get 6. Hydrogen equals to 6. Now the formula is 2 carbon, 6, hydrogen is 6. So we must write the symbol 2 carbon equals to hydrogen. This relationship indicates that this compound might have one double bond or cyclic structure with all single bond. Step 3, determine your path. So we have the relationship is 2 carbon equals to hydrogen. And we have 1 oxygen. So how we will determine the functional group? So 2 carbon equals to hydrogen means that we have C double bond. And if we have 1 O, so the double bond will be bonded to O. So we will have functional group carbonyl, which is C double bond O. When we want to write the molecular formula, we must know if C double bond O, we have 2 homologous series, which is aldehyde and ketone. Aldehyde is bonded with hydrogen and ketone when C double bond O bonded to another C. So now the molecular formula is C3H6O and we want to write a structural formula. So we have double bond, so we have 3C, 1, 2, 3C and we have double bond. And the double bond is bonded with O because we have 1 oxygen. And now we complete the carbon with 4 bonds because carbon can form 4 bonds. And we bonded C double bond O with H. So we have a structural formula of an aldehyde. How about we want to write for the ketone? So we write C, we have 3C, so we draw 3 carbon and the double bond O bonded to the center of carbon. And we complete the hydrogen. Now we have compound ketone. With this molecular formula, we can form two structural formula. One is an aldehyde and one is ketone. Example 5. So we have 3,3H6O2. Step number 1, write the number of C, H and O. So we have 3, 6 and 2 oxygen. And double up the carbon, so we will get carbon, 2 carbon is 6, hydrogen 6. So the number is 2 carbon equals to hydrogen. So the relationship is 2 times carbon equals to the number of hydrogen. So this relationship indicates that this compound might have one double bond or cyclic structure. Step 3, choosing our path. So we have 2 carbon equals to hydrogen and we have 2 oxygen. So 2 carbon equals to hydrogen means that we have C double bond. Okay, and we have 2 oxygen. Therefore, the functional group is C double bond bonded dengan one O and another O. And if the compound has 2 O, the homologous series are carboxylic acid and ester. Carboxylic acid, when the C double bond O bonded with H, form functional group carboxyl, and another type is C double bond O bonded with C and form ester with functional group ester or carboalkoxy. Lastly, step number 4, we have C3H6O2 as the molecular formula. How to write the structural formula? So we draw C, 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 and we draw double bond O and another O because we have 2 oxygen and the formula have double bond. And complete this compound with hydrogen. So we have CH3, CH2 and H. So this compound is carboxylic acid. We can draw another compound C, C, and we have C double bond O bonded with another O and the O is bonded with another C. So the compound is CH3, C double bond O, OCH3. So this is the structure of an ester.